Hello everyone, welcome to AP Calculus. This is the 30 most important question series on area bounded by polar curves. So this is the question number 3. Find the area of one petal of r is equal to 2 sine 3 theta. So let's start with this. So first of all, r is equal to a sine of n theta. This is called a rose curve. Here the n over here is 3 and a is 2. A is equal to indicate the length of the petal and n is equal to 3 since it is odd. When it is odd, so you can say number of petals is same as the n, which is number of petal will be 3. If it is even, then the number of petals will be double of that. Now in case of the sine, you can say first petal will be at an angle of, so what you have to do, just divide 90 degree by 3. Every time you have to do 90 degree divide by whatever is n, you have to divide by 90 degree divided by 3, that is going to be 30 degree. So first petal will be a 30 degree and the gap, how we can find the gap? Complete circle is of 360 degree divided by number of petals are 3, which is 120 degree. So the first petal will be at 30 degree and at a gap of 120 degree. So you can draw. So we will say the 30 degree line. This is going to be the 30 degree line. Now after a 120 degree gap, 30 plus 120 is going to be 150. So this is 30 degree line. This is 150 degree line and 150 plus 120, that is 270. So this is this line. So the three petals will be along these lines. So first petal will be this, second petal will be this, and third petal will be this. This is the rose curve. Now we have to find the area of one petal of rose curve. So let's figure out this one. So to get this one, again we have to find the radial lines. So you can say for radial lines means we have to find the alpha and beta. Put r equals to 0. So when we put r equals to 0, it is 2 sine 3 theta. That is equal to 0. So we can say sine 3 theta equal to 0. So sine is 0 at all the multiples of pi. So you can say 3 theta can be 0, it can be pi, it can be 2 pi, it can be 3 pi, it can be 4 pi, and so on. So if you divide all the angles by 3, so theta will be equal to 0 divided by 3 is this, pi by 3, 2 pi by 3, 3 pi by 3 is same as pi, and 4 pi by 3, and so on. And that you can see 0 and pi by 3. So 0 means the first line over here. The first line, the first radial line will be this. This is of the 0. Actually it is along the x-axis. So the first radial line will be over here, which is 0. Second radial line is this, which is pi by 3. And the third radial line we are in 2 pi by 3. 2 pi by 3 is this. And the next radial line is pi, which is along this. So in this way you can find all the different radial lines. Since it is asking us to find the area of one petal, so you can integrate either from 0 to pi by 3 or 2 pi by 3 to pi or along this radial line. So it's easier to go with the 0 to pi by 3. So I'll be taking, this is my alpha and this is my beta. So therefore we can say alpha is 0 and beta is pi by 3. So area is integration from alpha to beta 1 by 2 r square d theta. So 0 to pi by 3, 1 by 2 taken outside, r square. R is what? 2 sine 3 theta whole square of d theta. So here it will become 0 to pi by 3, 4 sine square 3 theta. Now we can change it. 4 can be taken outside the integral sign, and the sine square 3 theta we can write 1 minus cos 2 theta by 2. So 1 minus cos of double of this angle. Double of 3 theta is 6 theta divided by 2. So this is the integration we have to do. Now again over here, this 2 will be taken out and 2 times 2 will become 4 and 4 will get cancelled out. So finally we just have to integrate this 1 minus cosine of 6 theta. Integration of 1 will be theta and integration of cosine 6 theta is sine of 6 theta divided by 6 from 0 to pi by 3. So just put the values, pi by 3 minus, if you put pi by 3 over here, it will become sine of 2 pi, which will be 0. And if you put the 0, sine of 0 is still 0. So finally we are getting pi by 3 square units. So that is the area of one petal. If you want to find the area of 3 petal, just multiply it by 3. So I hope you have understood this thing. If you have any doubt related to this, you can send your doubt over this mail ID or you can comment down below. Thank you for watching.